Yes. One. We can take it.
Electronics and Instrumentation, Electronics and Telecommunication, and the Physics departments of the Annual Standard College of Engineering. I want you all to put your hands together and welcome our distinguished speaker for today, Dr. Shivali Agarwal. And I request Dr. Marinisa ma'am to kindly come and present a sapling as a token of respect and gratitude to Shivali.
Welcome. Thank you so much.
Thank you, ma'am. Now, I take this opportunity to introduce to you all our speaker for the day, Dr. Shivali Agarwal. She is a senior technical staff member at IBM Research Bengaluru. She holds a PhD in computer science and programming languages from Tata Institute of Fundamental Research, Mumbai. Shivali joined IBM Research India in the Programming Languages and Software Engineering Group in 2008, soon after her PhD. Over the last 16 years at IBM Research, she has driven innovations in areas like legacy applications, modernization, and optimizing IT operations by infusing state-of-the-art AI NLP techniques to solve complex real-world problems. Her work has been recognized within IBM for business impact and led to numerous outstanding technical accomplishment awards. Shivali holds 27 patents and has more than 30 conference and journal publications in top international conferences. One of her papers won the Best Deployed Application Award in AAAI, a top AI conference. Shivali received the Technical Rising Star Award at the Women of Color STEM Awards in 2022. She has served on the program committee of many top international and national conferences. Once again, I full-heartedly welcome you, ma'am. And on International Women's Day, she is the apt person here with us who will not only tell us about AI but also tell us how women are present in every field today, and you are an inspiration. Thank you, ma'am. Over to you. I'll give you one.
Hello everybody, good morning. Thanks for that introduction. And I'm here to talk about the emerging trends or the recent advances that we have been seeing in AI for the code modality. So what we plan to cover today this is the agenda for today. So we'll get into knowing that what when we say AI for code, how is AI influencing the whole software engineering field, and anything related to code. We first understand that what do we mean by that. Then we will, you might have already heard about large language models. I'll give a brief overview of large language models. It never hurts to have some repetition of basic things and these are the key things that are evolving. Then I'll touch upon that, now LLMs, even though they were they were in news in 2022-23 time frame, but now there is something more that has come. So that is, I would say, the most recent thing that is happening in the industry, which is LLM-based AI agents, and then we will jump into the industry use case where I'll try to show that whatever I've talked about in terms of all these pieces, that how do we really use it in a industrial use case, in a natural use case. So yeah, I'm from IBM, so I'll bring about something that the project that I'm actually working on. Okay. So first thing first, introduction to AI for code. Now we have seen traditionally artificial intelligence has been used for modalities like text, images, videos, right? And it has been used to solve problems around classification, sentiment analysis, and there are so many antivirus protection. Okay, so today what we're going to see is that how does this code as a modality? What can AI do for code as a modality? So I think code has emerged as a modality last decade, I would say, right? That's when it has really caught up the attention. And that's also because the models have become more powerful and we can do more with code. So that's how let's get straight into that. What can when we say AI for code, what are the kind of tasks? So when you think of AI, you think tasks, right? What can AI do for me? So when we think of code as a modality, what can AI do for me? So here are some examples that listed here. So the first one is code generation, code completion. I'm sure you must have seen a lot that nowadays everybody's just you give a prompt and it generates code for you. So this is the input is a natural language typically, or it could be code also, and the output is code. Right? So our application is low code, no code software. Then you have code translation. So you have some code in one language, let's say Java, and you want to convert it into another language, let's say Python or something, right? So that is code translation. And if you have to draw an analogy with text, then you can think language to language, right? English to Hindi, English to Kannada, and so on, right? So here it's something like, you think about code translation as from one language to another. Then code summarization, in which you give a piece of code, like your program or whatever, and the model, your AI system will tell you that what is it doing, right? It summarizes for you that what it does. It can be used for automatic generation of doc streams for code, right? So that's where it helps in productivity. Then we come in, we go a little more advanced in test case generation. Now, as part of your software development cycle, you write code, you understand, you write, and ultimately, I think the key is that whether it is working correctly as expected or not. So that has been always, I think, test case testing has been is an extremely critical piece, and so far humans have been doing it, mostly the generation of test cases, but here also now AI is making our strides, and you can provide input as a programming language or code, and then test case, you can actually get test cases. Maybe some of you might have, if you're working on code, then you might have tried it out. So it is a very powerful thing that it can do, and it's emerging. Then code clone detection, right? This is another task that AI can do nicely. So you have, you may want to see, you have multiple, let's say that in your repository there are multiple programs, and you may want to see whether there is a duplication or not. Or even if you have your students' assignments, and you may want to see that whether they've copied from each other or not, right? So instead of trying to do it manually, these kind of, you can actually automate it using AI models. It's called code clone detection. And then something called a program repair, which is like really advanced form of actually trying to, it goes into the realm of reasoning almost, right? So it is like you have your code, it is not.
Wait for 1 minute.
Yeah.
I don't know, I'll ask them to come forward.
Please come and sit in front. No disturb. Please.
Okay, so yeah, hi students. Good to see young faces. Okay, so I think this will be good, of interest to you, and I hope that you'll also be able to leverage it somehow in your courses and in your career. So yeah, I just covered this list. In the interest of time, I may not go over it, but you can. I think most of you will be aware of it. So we just go forward, and you can get the slides maybe from Trupti ma'am. So yeah, so going into the program repair, which is the last row here. So that's another very, I would say that it's an advanced application of AI into the programming space, where you have a program that is not working as expected, and then you give it to an AI model and it is able to repair it for you, right? So this is like really some sort of magic that it is not yet, I won't say that it is perfect, but yeah, that's where things are going. So I would say this is a good list of when you think of AI for code, typically your task will fall in one of these buckets, right? So this is the space of AI for code. I hope I've been able to, I know not everybody is from the background, from computer science or AI background, but I hope this makes sense, right? That these are the kind of tasks. And here I get into some examples of some of the things that we saw on the slide above. So this is code summarization example. Now here you can see you have a small, it's a Python code. There are a few lines, it's doing something. And below you can see that if if a human was to tell that what is this code doing, maybe they would have something, they would have said the last line here, human written, return the posting service with the given name. So that's the purpose of the paragraph, the method that is written there. And then you can see that how certain models, so here on the, so this was published as part of this paper, transformer-based approach for source code summarization. It appeared in ACL. And then they show that, how close the machines are in their ability to understand what this base piece of code is doing, right? So this is one example. Code generation, right? This is another very hot topic that is there nowadays. And here, I'll not get into, I think it's maybe it may not be very easy to read for everybody, but the essence here is that you tell what you want to do, right? So for example, if you have an input and then your P1, so P1, think about it as a prompt to your model. So you say define a list named elements with the values given in the input list. And then what your model, what your AI, so it's like think of it as an interaction, you're talking to somebody, interacting with somebody through keyboard. You tell it that, okay, this is my input, and you define a list. You can give step-by-step instructions, and then see, if you really see, then S1 is the source that it has generated, which is element is equal to this. And so it keeps on, you keep on telling little more and more complex things like scan through the list in order and remove all the zeros and store the count into another variable called non-zero, right? So you can, think about it, right? It's kind of complex. And it can actually give you something, a code out of that. And then you can, in code generation, so you do this. Nowadays you can give a single prompt and it will perhaps give you the full code in one shot as well. And then you get this full code here and you can execute it and check whether it is, the test case is also your model will give. So you have your input, the input you gave, this is the expected output, maybe it was in the test case, and then when you execute it, you can check whether the code was generated correctly or not, right? So this is one of, I would say, a good example of how things are going to be in future, or already they are like this, right? This is not even future. We are here. This is an example of code translation, where on the left hand side you have a C++ code. Right now, I don't know if students now even, they do C++, I'm not sure. So yeah, if you have, there are many enterprise softwares written in all languages because
We have C++.
You have? Okay.
Yeah, first year itself.
Okay, that's good.
Introduction to C programming
Is there? Okay. Yeah, because that's very good. I think it's important. Yeah.
Second semester C++ is there.
Okay. That's
object-oriented programming.
Okay. Good. Yeah, so yeah, just in case that, so you may have need for translation of code from, and this is something that, I covered in the use case that I'm going to show. So here you have, let's say, some C++ input, and then you may want to get it into Python or some other language, right? So this is your example of code translation. And earlier this code translation was done using classical techniques, but now we have the AI models have become intelligent enough to actually give you a reasonable amount, a reasonable guarantee of correct translation. So this was an introduction to what AI for code means, right? So I hope that you know that when somebody says that what does AI do for my code, or what are these new, how can I do it, what AI does for code modality, then this is what we are doing. And we saw some parallels with the text in which modality as well. Now let's get into the model part, right? So we are doing a lot of things. AI is doing, so somebody is doing this, right, for you. So there is this model, this is AI model, which is actually helping you achieve these tasks. So let's get into an overview of large language models. Okay, there is a history to AI models. It's not that, large language models were there from the time it started, but large language models are state of the art. This is what is getting used pretty much nowadays. So let's see that, and mostly these large language models are powering the tasks that I have shown. So let's get a little bit insight into what does large language model, what is a large language model? You might have heard this ChatGPT, right? And behind the scene, ChatGPT is actually running a model, the GPT-3, GPT-4s, right? You must have heard. So those are your core models which are powering the chat experience that you're having with your GPT models. Right, then you have Llama from Meta, Granite is from IBM, Mixtral is there. So these are all large language models. So each company they have their own model, because I mean you can if it's something open source you can definitely use it, but typically it's in the interest of big enterprises to have their own models so that they can train it as per their requirements and so on. So this, when we say large language model, what should come to your mind, or what essentially is going underneath? So you have it's basically trained on a massive data set, right? And I think deep learning part is of key essence here. This deep learning and self-supervised learning, I would say, right? So traditional models, what we had, you must have heard about support vector machines. I mean, there have been a growth, right? We had these random forest models. So these classical, they were supervised models. In supervised models, you would give the data and you would tell that what are the kind of features that, for example, if you have a classification task, you will tell that certain types of features is something that you need to look for in your data, and then you need to classify it as, let's say, hot or cold. So maybe you have been given certain data entries, and then you will have to tell, okay, you have to look at certain features, that if it is, the value is less than this, or whatever. So you actually you have to tell it, and you have to give it examples, sufficient examples for the model to learn that, okay, if I see a new data point now, then how can I classify it one of the existing classes. But the key part, or the key problem that got solved with deep learning, and that was enabled by massive data sets and the computation power becoming cheap. So that is, you didn't have to tell what to learn. See, previous to deep learning, in your classical learning, you had to tell what you should learn. What are the characteristics that you should look at in your data? But in deep learning, once it came, it had the intelligence like a human brain. Like if we can say by listening to some accent, whether it's an Indian, or maybe he's from Western country, or maybe a European country. Now it's just by data that we learn it, right? We have not been told explicitly that this is what you have to look for. We just keep on learning, and we keep on mapping in our brain, and eventually we are able to do it. So think about deep learning as something like that. That it just, you can throw a lot of data, a lot of things that are present, and it will automatically learn. It will understand the features that it has to look for, and it will be able to tell you the correct answer. So that is the power of deep learning, and it is self-supervised, right? So that's what earlier when we say supervised, we have to tell. So earlier it would be that you give the data point, and you also tell, okay, this is this, right? You tell it, like you teach. Okay, so this is, if you see this example, then it will correspond to, let's say, some hot or cold weather or whatever, right? Example. In this case, it can automatically learn. I don't have to give it examples of what is right, what it should do. So those are some of the things. So it is very good for language models, because that's what it is learned. And that's the power of it. That's why it's called large language models. Okay, and then it was actually, the whole thing got propelled once the transformer architecture came into picture. In the next slide, I'll show a brief history of how the models evolved. And then there is this notion of fine tuning. So of course, right now you have your data set, huge data set. It could be like, you're scraping the entire internet and you're training your model, and then but it can still learn very generic things, right? You may be able to generate sentences, complete sentences. You can do certain type of things, but maybe it is not very good in a task specific to your domain. Maybe financial domain, stock prediction, right? Something like that. So you may have to train it. You may have to fine tune the model by providing training data specific to your domain, and then it will be able to fine tune its learning so that it can perform better on your domain, right? So that is the aspect of fine tuning. So this is about large language models. Okay, a brief history of how this, how it has evolved. So around 1960s, maybe we had the first system which was conversation systems, where 1960s, next time I have it. So it was ELISA, and it was, we can say it was the first ever chatbot, and it was designed in MIT, and it was more like a simple program that used pattern recognition to stimulate human conversation, and it worked on some kind of a predefined rules, right? So that is how you can think. So if you really think, the start has been from rule-based systems, where we will define, okay, this is, if you do this, it's like a flow chart, right? It's like a rule-driven system. So it's very deterministic in nature. Then, a lot of progress got made. We had these, I mean, it doesn't capture it here, but down the line there were these supervised models that came along the line, right? And then there was this there was this thing called long short memory. So LSTM models came into picture. So LSTM models, so you had these normal or classical AI models, and then this neural networks were also, people were working on it, right? Fuzzy matches and all those things. So neural networks came, and then in neural networks you have these, you have your focus or attention on, it has some sort of a short memory, right? So you will focus on certain parts of your text, your input as it's coming, and then it may tend to forget what it had seen in the past. So when LSTM came, it sort of, it removed that limitation, or it enabled the models to be able to refer to somewhat in the past also. So that is what you mean by long short-term memory. So they really allowed for the creation of deeper and more complex neural networks capable of handling more significant amounts of data. Then there was this, in around 2010-11, there was this, from Stanford, you had this NLP suite. So at that point, natural language processing, around 2010-11 time frame, there was a lot of research being done around natural language processing, how to understand, how to get, the things like these pause tagging and name entity recognition, and these were things that were really being worked upon. And at that point, there was this core NLP suite that was introduced by Stanford that really pushed the bar, and that really made NLP, natural language processing, very, very, real, very good, I would say, right? So, and then there was this, so that was more about syntactic, right? You could understand verbs, nouns, and entity recognitions and sentiments and so on. Then I think the big leap came where Google Brain, and from Google we got this word embeddings, where you could actually take a natural language, right? You had these sentences, a sentence consists of words, and these, what they did was they came up with a notion of word embeddings. So you could represent your natural language as a vector, right, in some n-dimensional space. And based on that, you could actually infer semantic similarities. So that was really a jump from just being, grammatical, understanding the text grammatically, to being able to understand the semantics that are present in your text, right? Whether so if you have king, and then I think that was a very famous example that they showed in the paper. So analogous of king is queen if you change the gender, right? If king is male, then what is a female? So queen, it could answer with that, right? So that was really a big leap that happened. So word emerged, right? Word to vec. And then came the transformer architecture. And transformer architecture, again, it set the foundation for large language models that we see today. So there were these neural networks, RNNs, CNNs, they were there. I mean, everything has been pushing the bar, but these are some snapshots which have really taken it to the next level. Okay, so post the transformer models, I think now we have these, so 2017 we had the transformer architecture from Google, and now, and then in 2020, this GPT, OpenAI came up with GPT-3, which was based on transformer, and this was sort of a large language model itself, these characteristics which we saw here. Right, so that is sort of the evolution of your large language models. A lot of things have played a role in making it reach where it is today. Now, okay, so I think this is, I've covered this to some extent, but now we have these large language models. So how do you typically train it? So now, these models that you see, these GPTs or Llama, right, Granite, so it is all pre-trained. And it is pre-trained from the data that those particular, so somebody is owning, right, there's a lot of things involved in training such huge LLMs. So it goes, it can go over weeks and weeks, and there are a lot of cycles, phases of improvement, of benchmarking and things like that. So when you think of LLMs, so there is a lot of effort that goes into the training of these models. So there is this pre-training. So these GPTs and all are trained on vast amounts of data, allowing them to learn a wide range of language patterns and structures. Right? And then these models excel at generating coherent and grammatically correct text on a variety of topics. So from now you can see that this LLMs have enabled us with generation tasks. So far the tasks that typically AI models were used for were like classification, question answering, kind of, an answering or even some sort of, intelligent search you can think of. But now with these kind of training mechanisms that came with the transformers and, post that, with vast amounts of data, now it is able to generate, like you just give a topic and it will generate an essay for you, right? So, and it will be grammatically correct. So that is what it has enabled for us. So, and then there is this fine tuning of models that I mentioned that, for example, large language models are typically trained on your vast amounts of data. Now, if you have to do it for code, right? Let's say something around, so you may have to actually show it a lot of this code-related examples. It could be code can come as a pre-training also. And in fine-tuning, you may want to just fine-tune it on a smaller data set. So your pre-training is on a huge, massive data set. And then you can fine-tune for the task that you are interested in, or that, that the smaller piece that you want to focus in, or that's what your objective is. And then you can show it a very nice, curated, good set of small amount of data, and then these models get trained on it and they become highly effective for those tasks which are kind of more focused, right? So that's what we call it as fine tuning of models. And then you have a multimodal. Multimodal is that you and typically I think a few years ago there was this huge craze around generation of images. You just give what you want as an image, and then I think Midjourney and then DALL-E and all these models are there. So essentially multimodal models are that they can work with text, image, video, and now code also, right? So code also can be thought of as multimodal in some sense around with that. So these are, I would say that you train, and if you have a multimodal, then of course even for multimodal models, you will have to then appropriately show them that those kind of training data sets, right? So pre-training models with vast amount of data and fine-tuning models, right? So that's typically it. And the third step is prompt engineering, which is more like how you interact and how well can you ask your LLM or your model to answer your queries, right? So that is what That's how you extract the maximum out of your models and how you make your models good, right? So this is about LLM training. Now, these models are there, and so I gave an overview of large language models. These large language models, similar stuff goes when you have these models, when you use them for code. Okay, so here, when you are working on these models, when you are using these models, then there are, what are the evaluation metrics? So it's very important to have these kind of evaluation metrics in place. Whatever task, let's say you're using. So one is for the training itself, right? So training will have a different type of benchmarking, where it will see that on a specified, and it will be like, there will be a lot of benchmarks available, and then you can say my model achieves this much accuracy, right? So that's what you might have heard when people come up with new models. Now, here when you're using the model, let's say that model is supposed to be good, and now you're using it, let's say, for your code summarization task or your code generation task. So how do you measure that it is doing well, right, on what you want to do? So these are some of the metrics. Functional correctness. So here you can run it and you check whether it passes your unit tests. Text similarity is another metric where you can say that the character token level ended distance between the generated program and your goal program. So this is, let's say, for code generation, text similarity can be one, functional correctness can be one. And there are program-based techniques are there. Then there are hybrid metrics which will take your text similarity, functional maybe, and your program analysis-based techniques also. For example, it will also see whether the abstract syntax tree, how close they are, right, and between the generated and the goal program. Now, and the last one talks about, and this is not a comprehensive list, this is just to give you a flavor that when you are using LLM models, you need to also keep in mind what is the metrics you're going to use for your evaluation, whatever you're using it for. And it's not, in some cases it's not really easy because humans have to tell what is correct. And so it's not that you can generate on thousands of data points and get your metrics, right? So it becomes a little. And this is also a research topic of how can we even automate and these metrics, right? So for example, the last one talks about the task of code summarization. Now here the task, if you recall, it was you are given a code and you could tell what does it do. So what are the things you should look for when you're evaluating your output? It should be concise. You cannot have a lot of repetition of same thing. It should be specific. And it should tell what it is actually doing, the quality, and it should be able to tell all that is doing. You have three functionalities and it covers only one functionality. That is not a good thing. You have missed two, right? The one that one functionality that it covered, how well did it cover that? How repetitive it was, right? So those are some of the characteristics of your output in terms of when you're doing code to end. So this is just an example. So keep in mind that you have to take care of these things in mind if you're planning to use AI models. Now, I think I'll skip this and get into the. So we have time till 11:30, right?
11:30, even if you take it to 11:45.
It's okay though. Then I think I'll get into the use case. So I thought I'd give a background on what code tasks and what is LLM. So there is this, these are large language models, and if we really see that there are these what these models can do, but still they lack something. So at this point you can you give some prompt and it will give you an output. So currently if you just use off-the-shelf models, and they lack the power of reasoning. So for example, if you ask a question like, aside from the Apple remote, what other device can control the program Apple remote was originally designed to interact with, right? So this is in the research paper, you can refer to it. It's a very well-cited paper now. So, and I think this is because this is all emerging trends, this whole program is about emerging trends. So we have to consider, so LLM is now no longer, I would say, an emerging trend. This is your emerging trend. That how do you use LLMs further, right? How do you actually make LLMs reason? So if you have such a question, then you have to, it just shows, so this slide shows that what could have been your standard answer without the power of reasoning. And then if you only, you only thought about it, okay, let's think what could be done, then you would have landed with certain type of answer. Then if you only had actions with you, then you could only take actions. I can only search, right? So then you can only give some amount of search, and then you will end up with some kind of answer. But the reality is that you have to reason, and then you have to take action. So it's called a chain of thought, react plus action, whatever. Like, these are the key things that are that's the core of the matter. So this is, by the way, this on the right hand side that you are seeing 1D, thought, action, observation. This is all LLMs. It's been driven by the agent. It is not that a human has not done that. So the LLMs have been trained to now take an action. So for example, the LLMs that we had, if you ask like what is the weather today in Bangalore, it would not have been able to answer. But now the LLMs have reached a stage where actually they can issue an API call, and they can maybe connect to a website or something and get the weather for today and show it to you, right? So that is a level of, that's where the whole field is progressing. To be able, from your query, to be able to understand what is it that I'm looking for. Is it available from my knowledge base, or do I need to do I need to act upon it by contacting another system, being able to call that system, take a reply from that system, see if that reply indeed answers my question. If it does, then give it as a response. Otherwise, ask a follow-up question and repeat it till the model thinks that okay, I have the answer. This is where the field is progressing. I would say this is the key emerging trend if you have to really think about it in LLMs. Okay, so reasoning, being able to reason and take action. Okay, so this was about LLM agents. So I think this is maybe you can, this is publicly available. This is in the paper. If you're interested in reading, I think there's a lot of material already available in form of blogs and other things. But I hope you got an idea of what I mean when I say LLM agents, right? It's the ability to be able to reason and take action, not just being able to generate something from my knowledge. It goes beyond it, right? It's able to reason. And this is the kind of, so that is what is called agent, and agentic framework. In fact, I think Sam Altman also said, right, that 2025 is going to be the decade of, the year for agents. So yeah, so I think this is what we have. Sort of, this is agent needs to plan. It has some memory. It has its tools. Tools are the APIs or the functions that you can call to get your responses, which it may not have in its knowledge or memory. And then it has the ability to act upon it, and then it has the ability to plan, right? So reflection, self-critic, chain of thought, decomposition of rules, and all these things. So it really goes into the realm of how humans are able to reason and act. Now with this, let us see that whatever I have spoken so far, I gave you the tasks at AI for code tasks. We've seen LLMs, and then we've seen agents, right? Agents using LLMs. So now let us see that how does it all come together in an industry use case. So I'll be talking about a use case that I've been working with. It's called application modernization, and this application modernization. What I'm going to talk about is coming from the challenges that we are facing in the mainframe environment, mainframe applications. So it may be surprising for a lot of folks here that these mainframe and the programs written in these legacy languages like COBOL, PL1 are still very much in use. In fact, 43% of banking systems are built on COBOL. 220 billion lines of code are in use as of today. There is this, and 95% of ATM transactions are handled by COBOL code. So you can imagine the kind of implications or the importance, relevance this mainframe systems have on us today, right? It's still very much in use, even though I don't think any college teaches COBOL nowadays, right? So it is a legacy language. But the truth of the matter is that the software exists today. The legacy software exists today. It is being used, and there are a lot of challenges henceforth. So the age of developers, right? So people who did these systems were maybe developed 30, 40 years ago, and the challenges being faced are that the people who developed that code, they may have retired by now. The developers who understand, who know COBOL, they are headed towards retirement, so they are in typically 45 to 55 years, you can think, the youngest ones, I would say. And so this is, it is becoming increasingly difficult to maintain such applications, to be able to keep at these applications which have been very traditional in their user interfaces. So I don't know, some of the faculty may remember that we used to have those dumb terminals, right? And we used to interact with the systems behind that. So how can we, the challenge, when we talk of modernization of those systems, essentially what we mean is that how can we actually connect them with modern interfaces like mobile, web, right? Some of those things. And that's one aspect. And then the other aspect is that how do we make them more modular? So these languages, COBOL, if you even see, these are all procedural languages. There is no notion of object-oriented and things like that. Even though there were guidelines given that you should create a function and you should have it modular as much as possible, but still the fact of the matter is that you have single programs, and I'm not exaggerating. There's one single program can span 100,000 lines of code. So it is doing multiple functionality in a single program. So I myself seen it, so it's not an exaggeration. So there is this, it is a nightmare to maintain such code, right? You have to make changes. Now we are dealing with financial banking domain, insurance domain. Regulations keep changing, right, so fast. And everything has to be done. You have to make changes. So it's very important that these applications, they are modularized, they are made more maintainable, and of course it is, they are made more easy to interact with the modern user interfaces. Right? So these are all the things that we want for mainframe modernization, and it is really important. I think we've already made a statement on why is it important. Now. There are a lot of challenges also. We saw that there is this whole population which is retired. The SMEs are not there. COBOL developers are not there. The code base is huge, millions of lines of code. There are a lot of systems are interacting with each other. The code has been optimized. So there are portions which are all written in assembly language also. Yeah. To take the juice out of the very last bit of the computation power that you have. So the whole thinking of writing code has been to just to be very efficient, to be very optimized. The readability, maintainability, those things were not primary. They were not the main things at that point in time, because the computation power was very expensive. Now computational power is cheap, right? Somewhat relatively. But anyway, so I think we have large code bases. Highly interdependent, tightly dependent modules. It's very difficult to trace manually. If you want to, you just get lost in the code. So and then the maintenance, right? If you may have releases, it may be, and typically the test cases also will not be, like how we have. There is no CI/CD pipeline. There is no DevOps there. Those are things that we're trying to introduce as part of modernization. So. So this was, I gave a background of what the problem is, right? What are we trying to solve? So we have these legacy applications, and we need to modernize it. And modernize can have lots of flavors. I'm not getting into that much of detail of what kind of modernization can be done. But here is this is something from our work that when you think of modernization, application modernization of legacy code, and this is not just COBOL, even if you have to, nowadays you even have Java legacy programs, right? So this is typically the cycle that you will follow. So the first one is understand. So understand itself is a very critical piece. What is my application doing? What are the dependencies, right? What are the functions that I need to extract out, I need to modularize. So that is your understand piece. Then you need to refactor. So let's say that you want to modularize it. You have 100,000 lines of code. Maybe slowly you will want to take out certain portions of code, create new services, have API specifications generated for them. So slowly maybe you will convert it into modules or services. Then in some cases you may even want to transform your code, right? So for example, we have COBOL. Now, as we see that COBOL is a legacy language. Hardly anybody is learning it nowadays. So you may want to translate it to something like a Java, or maybe some language which is more modern, for which you will get skills. So there is this, as part of modernization, you may decide, and that's something that is very, very client specific. They may want a certain code to be retained in your mainframe COBOL. Some portion of the code they may want to transform into Java. So that's very, very client specific. There is no one pattern that we have seen. Now, whatever you have created as a service or you have translated, you need to validate, right? Whether you've done it correctly or not. And that itself is a challenge because there are no test cases, realistically speaking, that can be leveraged from the legacy system. So a lot of work and effort goes into the validation piece as well. And then there will be the deployment piece, and then once you have deployed it, let's say in your cloud architecture, if you have services, then you will have all those monitoring. AI ops is another field. We are not covering it, but that is another. How does AI help in your operations, monitoring, observability, right? That's another whole piece of research that is there for where AI is very, very useful. So that will come under the number 6, which is observe. So this is the flywheel typically, which is our blueprint for modernization. Now, if I have to map it to what we saw in my first phase of the talk, so here, how is AI helping us? Now, a lot of this 1, 2, 3, 4, 5, whatever we are doing, it can be done through classical techniques also. But definitely, we have seen value of using AI. And as we will see, there is a value in using AI plus classical techniques, right? That's where you can get most power. And that's where agents come into picture. So I've given this so that you can get a sense of how this understand, refactor, these notions that we have in mind, how do they map to the code tasks that we saw before. So for example, understand, when we say, it can understand typically, you can think about it as code summarization problem. So you have been given your COBOL code, maybe like, whatever your program, paragraph, whatever, and you give it to your AI model and it will tell you what it is doing in English language. It's a very good thing to get started with, especially if you are not very familiar with COBOL or the languages. And then there is this AI agent powered chat. So you may, as part of, and this is what we will deep dive into. So I'll not, we'll see more around what understand does. The other piece is refactor. You can think about it as, it can enable, it will leverage code generation. So you will tell that, okay, this is the piece I want to refactor, and it may have code completion, code generation, code modification, those kind of aspects of AI you will leverage here. Then this transform is code to code, right? The code translation task that we saw. And then in the validate, we have this test case generation. So if you remember, I had said that test case generation from code to test case, right? So these AI helps us with this. So these are some of the ways in which you can see that the use case maps to your AI tasks. Okay.
I don't know. How much SDLC, software development test, previous one, previous slide.
Yeah, so see, software development life cycle is typically when you're developing software from scratch, you will not have refactor as such, right? You will have design document. First of all, you will collect requirements. You will then you will have your design cycles. And if you're adopting agile form of development, then you will
Tests.
right, and then you will develop tests, right? And all those things will be there. Then you're doing something from scratch. So that is your development from scratch. And then there, as part of maintenance, there you will have your bug cycles, you may have bug fixes, and some of it may get into the requirements, new fresh requirements or those kind of things. This is more like a reverse engineering.
It's like a reverse.
Yeah, this is more like a reverse engineering. So you are trying to understand what exists, and now you are trying to either mold it into a different form, right? Into something which is so you have a state A and you want to take it to a state B. Right? So there is a difference there, but so there will be different these modernization projects will also have some kind of software development life cycle. So these things may trigger some SDLC, right? For example, you understand and then you decide that you have to refactor this piece. And then once you have decided that, then there may be ultimately it will boil down to trigger, okay, I'm writing code for this, it will get into my main code stream, and then I have to trigger my test cycles and all those things, right? So that will trigger your SDLC, but from this perspective, this is a slightly different cycle you will follow, where you will, first of all, based on the business, you will decide where you want to modernize, how you want to, what is your path to modernization, and then here, yeah, so some of these, there may be some overlaps between your modernization life cycle and your development life cycle.
Is it like something customization of this existing system you are modifying?
Yeah, this is something you're modifying, yeah. So, think about it like refactoring, right? I mean, we have to refactor a code at some point. We all take up this technical debt builds up, right? So, as part of code, you're writing code for 1, 2, 3. Many people are writing code. So, eventually it becomes like a mess, right? Okay, very so then you have to take up that activity where you say, okay, I will clean it up, I will make it like this, right? So, that is one part of doing it, and that is typically what refactoring means in our software terms. And here it is more like, you can think about it that my input is slightly different in this case, and my outcome is more than just refactoring. That's my metrics of measurement of success may be different. Okay. Yeah, any more questions? Maybe we can pause and take some questions and yeah, fine, that's okay, I'll cover it as and speed it up.
More questions?
I mean, is it making sense?
Yes.
Yeah, it's just, I just want you to appreciate that, whatever is happening is realistic, right? And it's very, very relevant, all these developments. It's not just some fancy AI thing that is being worked on, yeah. Okay, and it is a huge, tremendous business impact, right? So, okay. Going forward, so in this flywheel, what I'll be focusing on is this understand piece. Each is a topic, by itself. It can take one session each. So we get into this understand piece. Now, this is more into that, when I say understand, application understanding. So what is it that I mean? So this is an example. So this is a COBOL syntax. COBOL has a notion of paragraphs. And this is your subtract exemption from salary. So it's more like COBOL is very close to natural language in that way. So the user selects a code fragment and whether a program, paragraph or lines of code, and wants to understand it to know what it is doing. So and they may also want to know more specific things when you are understanding, because your goal of understanding is to make modifications to the code, right? It's not as it could be at a business analyst level where you're trying to understand what it does, but as a developer, your goal will be to make modifications, right? To make changes to the code. So you may want to know that which program calls a given program, which variables in this paragraph are local, what statements set the value of a particular variable, right? So you will try to understand, when you are trying to understand the code, these are the typical things that you want to know, the dependencies, the variable usage and things like that, right? So that is what we need. And challenges in understanding legacy applications. So as I said, so there is this, manual code scanning is literally, it's going to take weeks and months. There is no documentation as such. Even the code comments, right, which are unreliable. So imagine that the code was written 30-40 years ago. There's a file, and then if you can see in the code that there are these in 1970 somebody has written a comment, and then you have a comment from 2010. So and it's very difficult to rely on the comments. That can be a research problem itself, and how do you see that how this program has evolved. So code comments are, in modern software, code comments is what all the AI models want to leverage. It's so easy, README files and so on. There is nothing like a README file typically in your COBOL projects on mainframes. So yeah, these are all the real challenges that you face when you deal with mainframe legacy applications. And of course, the knowledge drain. There's SMEs are retiring. We don't have a new crop of COBOL developers, and all these things are there. So it's something that is really reverse engineering the code also. The understanding of your application also has to come from your code, because there is no guarantee that your comments capture what is there in the code. You may, if you just leverage the comments, the English comments that you have, it will be very different from what the actual thing is there in your code, right? So that's where it's important. Those are the challenges. So we have a need for automated tools. I think we've made enough points, so let's not get into this. Let me get into the solution. I think that's what will be of importance to us to understand, to connect a final dot between what I have spoken. So the existing solutions, how we understand today. So there is this one whole piece of work which is static analysis. I don't know whether computer science background folks here, but otherwise I think other folks may not really know what is static analysis. But static analysis is a way in which you can, if you have a program, then you can get the control flow graph. You can get an intermediate representation of how your control is getting transferred from one statement to another statement, between one program to another program, how your variables are flowing through your program, right? So that is, and what it does is, it does it statically. It builds, it does not, so this is the classical way of extracting insights about the code. And then once you have these intermediate representations, then you can write algorithms which can help you solve specific problems, and there are a lot of tools available for that. Then you have now the modern generative AI LLM based solutions which can explain the code, but then they suffer from hallucinations, and the other big challenge is the context. So now, as we saw, right, that your application, legacy applications or any application can be millions of lines of code. Static analysis will be able to deal with it. That's on a limitation for static analysis. But typically in your AI, in your large language models, you have only a limited, it's like how many tokens can you give in a prompt. That is what it can analyze. So that limitation is there. You cannot just simply give it the entire million lines of code and it will be able to answer. No. Right? So that's a real limitation, and of course now we see that everybody is saying that this context limitation will go away in some years, but still the reality today is that there is a limitation like that. Okay, so now we have seen that there are these siloed techniques, and what we want to do is we want to bring the best of both worlds together in a solution. So that is where agents come to our rescue. So we have seen that agents have essentially, they get the brain from LLM, they get the power to reason, and then they can take action. So in this case, what we are saying is that what we will do is we will give our agents, so you remember I talked about functions. that the agents can call. So in this case, they will be the static analysis function. So they'll have access to the information which is obtained from static analysis, and they will be able to leverage it and then use it to be very precise and to overcome some of the limitations that we have seen that LLMs have. Right? So that's the power of agentic frameworks. Now this is the solution that we have currently for this application understanding. It uses a React framework. If you remember, I had shown a slide with React framework, reasoning plus action, and it's actually that's one type of way in which agents can work. There are other types of ways also in which it can work. So there is a whole of literature, but what we have solution currently is that we have developed a solution based on React framework. LangChain is a platform that will give you different types of agents that you can instantiate. So LangChain and RAG is another very useful thing. It is retrieval augmented generation, right? So LangChain and RAG are the technologies that we are using. And then there is something called an IBM ADDI. So ADDI is a tool, is an IBM tool which does static analysis for us. Okay, so you can think about it, React, LangChain. Of course, there is an LLM out there. I mean, we are not, that's an implied thing that LLM is sitting there somewhere. But the agentic flow that we are talking about will consist of these pieces. Okay, so there is this ADDI. So I'll just get into. So ADDI is application discovery insights essentially. So here on the left is actual sample of your COBOL code. So this is how your data division looks like. Then you have these procedure divisions, right? So this is how typically the code is written. And what ADDI does is it parses all your code, and it understands it's a very comprehensive static analysis tool, and it will give you all the relationships in form of relational database tables. So all you need to then do is that whatever you want, you just need to query your tables, and maybe you will need to build up some, again you may have to build some graph or something, and you will be able to then directly know that what interdependencies exist, what are the variable usage, and so on, right, from my code. So as you can see that this becomes the power of the classical analysis that we want to leverage along with the power of LLM. So for example, this is just an example. ADDI agent is, so this is your user query comes, okay, and let us say this is our system. So this ADDI agent, what you see here, it is built on that LangChain, RAG, it has all those things. And it is powered by this LLM, and this is, we use an LLM from IBM, it's called Granite range of models that is available on Hugging Face. So you can have these ADDI agent will then the query comes, it does all the reasoning, and it understands the query, and then it will. These are the tools. If you remember, there was this function calling thing that we had in LLM agents, and these are sort of your functions, right, that are available at your disposal. So the agent, with the help of LLM, is able to reason out what is the tool, what is the function that I need to call to answer my query, and then these tools are at the back of it. It is powered by the database that we had built, right, analyzing the programs. And then what the function will return you some response, and then it will be massaged into a nice natural language response, right? So this is what the application understanding does, and here is a little more detailed architecture. So you have the LLM is the Granite 3 models. These are the, and then the functions are called based on APIs, and then we have these, user query comes. So this is a little bit of a detailed thing in terms of there are some more boxes shown here which I will not get into, but essentially what the key takeaway for you is that a lot of things are happening here. So we are actually, it's the agent, the ability to reason, ability to take action, to know what I need to call. But all those things are happening for us to be able to do something useful for the user, right? So this is just a list of tools. For example, list all the available programs, get the SQL tables used in a given program. So your program itself is using some DB2 tables or something. You may want to know that what tables it is being used, right? And so what the call correlation. So there are a lot of these examples of the functions that we have built, which are then exposed to our agent. And internally, when the agent, what are the capabilities of the agentic system, right? In addition to whatever we saw on top of reasoning and also query decomposition. So now that when I ask a user query, for example, if I ask that, give me the programs that use the same table as being, as used by some other program. So in that case, what you have to do is that you will have to first, get the tables for you have to essentially do a query decomposition. You will not be able to directly get your response in a single question, right? It cannot be mapped to a single tool. You first have to understand. So that's what we mean by query decomposition. Then NL2, this is a very specific, you're talking about the use case here, and because our knowledge, our static analysis knowledge sits in a SQL database, so we also need to leverage something called NL2 SQL. Now there are LLMs for doing this also, and then there is this context awareness. So we have to use a chat history. You need to leverage your history because the user may ask this, that, those kind of contextual questions may come. So these are some of the key things that as part of a solution we have to, we are taking care of. This is on the right hand side, this is an example from the working system, it's a screenshot. So this is built into VS Code IDE. On the top right you can see that this is the question / explain, and then below you can see that whatever the user query is, and then the response it gives like a chat, and what are the explain and insights, API insights and so on. And on the left hand side is another web-based experience that we have for this kind of a system. So this is essentially, it will be exposed. So this, it's also kind of, it's important to visualize what's happening. So you will either have a web interface to interact, or like a chat GPT, you have, you just have a web UI where you type in your question and your response comes back. So similarly here you can have an IDE-based experience, wherein an IDE you will have a chat enabled. There will be a plugin which will enable your chat, and then you can ask your questions, and then it will be able to respond to it. But underlying the machinery, I have shown you what all gets triggered, right? It will go to that agent. The agent will think, okay, what I need to do. Then it will do all those chain of thought and actions, and then giving back the response. So that's the machinery that is being triggered behind the scenes. Now, so this is what I showed you with this it's deployed on cloud, and of course, for deployment also there are a lot of things that we need to consider. Scalability, data privacy is very important, because as we see, right, most of the applications for mainframe they don't want even a single line of code to go to the cloud, because they hold it very tight to their environment. It's very sensitive data, and all those things are there, right? So privacy is very important to our clients. So a lot of these things also have to be considered as we deploy our solutions. Then what are the challenges that typically we face? So whatever challenges are there with LLMs, we continue to face hallucinations, and with agents, a new type of challenge comes where if you remember, it's a chain of thought, right? So it thinks, it takes action, and then it observes the output, and then again it kind of gets into that chain. Many a times it may have reached the correct answer, but still it does not understand that it has a read, and it keep on asking. So those are some of the things that we have observed as things, as challenges, and things that we may have to either somehow we need to overcome those challenges. A lot of work is happening in all these areas independently, but yeah. So context management is another thing which in our case we have somewhat able to handle, because we take the static analysis. So we have overcome it through another means. But LLMs still continue to face that challenge. And then human AI collaboration. So developer trust and usability. That's another very important piece, that if I'm going to make business critical changes to my code, can I trust the output that I'm getting from my AI? Now I think today's generation, they trust the AI very much. They are very happy with it. But I think our generation, we will look at it and we will verify whether it is right or wrong. So the trust issues may be there. So that's where I think the evaluation benchmarking is very critical to give confidence that, yeah, I know what I'm seeing. At least say I'm 80% confident, 90% confident, things like that. Performance and latency. So yeah, I mean speed, it can be, if quality and speed sometimes can be in conflict. So handling that, security and compliance is of course very critical because of the nature of the clients that we have. And yeah, so this is agentic framework versus traditional methods. So static analysis and AI agents is what we have shown. Yeah, it's sort of, it's all there. So it's query processing is a robust understanding. So we can be more confident in our responses because we are sort of grounded in static classical analysis. We're not just, it's not just AI. So we are a little less impacted by hallucinations. Okay, so I think as I was talking, I also spoke about some of the lessons learned from our implementation. So, like I said, right, what we discovered while building the system, that we face those trouble that it may not stop at the correct answer, it may keep on going. Then, balancing automation and human oversight, performance optimization. So, I think I touched upon it as I was speaking. These are, of course, future improvements and research directions. So, keep enhancing the AI explainability. I think that's also a very important piece, that if you get a response, then can I trace it back? Can I explain why did I choose this response, right? So, for example, there is this, if you are giving a response, can you actually map it to the document that you got it, right? That's how search works. But in generative AI, we do not really get the lineage of the information, but maybe something around that. In our case of understanding, maybe it's how did I arrive at some reasoning or some explainability will be very useful to build the trust of the user, right? And then adaptive learning from enterprise data. So training is going to be it's always that will be a topic for research and improvement always. And developing more secure, unbiased, there are all those, fairness, all those things anyway, we covered yesterday. So those aspects will always be there. In code, maybe not so much, those aspects, the bias and all will not be that much. But yeah, security is always, and confidentiality and all those things will be there. So data leakage is another important aspect, and that's where I think a lot of these code issues, the training, that what have you trained your model on? It should not be licensed software or it's something confidential. So if you've taken a repository from the internet to train your model, was there an agreement given that yes, my data can be used for generic purpose training, right? So that kind of thing is also very, very critical, and it's going to become even more as we go forward. There's going to be a lot of competition between models. So what is the lineage of your data which was used for training? Did I encroach upon some confidential data not meant to be used for training? So those are a lot of, you may not get into training as such, but just letting you know that that's also a very important piece that decides how your model will eventually perform, right? So yeah, I think that's more around LLM thing. Key takeaways, yeah. So I think agentic frameworks are here and they are pushing the boundary. They are trying their best to replace, to do what humans in terms of reasoning can do. So agentic frameworks combine AI. For us, it's like in this specific case, it's like they combine the AI and static analysis for better application understanding. And the proposed system improves modernization efforts. So the productivity is there. At least it becomes tractable, right? There's this whole problem of application understanding. And then, of course, there are these real-world challenges and considerations that need to be taken care for enterprise deployments, right? So these are from our use case, these are the key takeaways. Yeah, and thanks everybody for being If I have any questions, anything.
What performance metrics normally used to have for these AI models evaluation?
Yeah, so it depends on your use case. So for example, if we take our use case of understanding, so if you take the task of summarization, so there will be the metric that there should be some bold standard truth that for this, so you will see that how close, how concise, I think I covered that concise, precise, succinct and all these things are there. So that's quality measure is one, right? And then how quickly it comes up with a response. Does it come up, sometimes agents can get stuck also. So I think those are, you can have the benchmarking on how quickly it is able to respond. So those are the things that you will evaluate your performance. But the metric may also be governed a lot by your use case.
Madam, it was some latency. How much duration approximately? How much delay?
It's latency. So yeah, that's a deployment thing that how you deploy it. But if you're using, for example, if you are just using LLMs, then it'll come very fast, right? There'll hardly be any. It is just taking it's processing. I can't give you numbers, but I'm just giving you the idea of what brings in the latency. But now let's say you come to agents, then it has to call APIs. So now network is involved, right? So you have to then maybe it will be multiple APIs that are called. There will be some processing time involved on another network and things like that. So a lot of it will also that's where a lot of things, the deployment, placement of your containers, a lot of things will determine how the latency, how well you take your latency. But these AI agents may bring in a bit more latency.
Can you summarize the limitations of LLMs?
Yeah, I think we had, we have this hallucination. I think this one that's, for example, so if you have some, variables, a variable, let's say, can take a value 1, 2, 3, 4. Okay, that's enough. Okay, as a human, I can see it. And while explaining, it can tell that 5, 6, 7, 8 also. Okay, so it will tell what exists, but it may tell, something, it will just make up some things. Okay, which it's a little scary sometimes. And that's where the trust issues will come in. Then and the context length is a very big limitation, I would say, right? That and things are happening, research is happening to handle more and more context. So context is in your prompt when you interact with your model, with your LLM. Typically, that you give a prompt to it, right? And in your prompt, you typically also tell it that this is my question. This is the format I want my answer in. You may even give us some sample output. And then you may ask your new question, right? So a prompt can be very huge. You may even give some context information in your prompt. So it can run into multiple tokens. So that's where a limitation comes that you may not be able to handle, let's say, more than 1,000 lines of code or something like that. So that's another big limitation. Especially if you're taking use cases like ours, which deal with huge number of things. In some cases, that context length may not be a limitation, right? And then I think this data leakage is another thing that has to be that in your while training the model, right? Like how much, what is the kind of data that you used, and there are these things around indemnification of the data I used and all those things are there. So those are high level things, and I can go back. I think I had a slide. Let me see. Okay, food model challenges. Yeah. So I think for the code, I think I have these things testing. So the output, the validation of output is also a challenge. That's right. I think those are some of the things, and benchmark quality and leakage is what I mentioned at the bottom. So we look at overall hallucination, context length, testing, benchmarking, these things remain challenging because these tasks are complex by nature. Okay. Thank you everyone. Thanks a lot. I hope, even if you were able to, now somebody asks you what is AI for code and you can answer that, I'd be happy that, my thought was useful. Thank you.
Thank you, ma'am, for the wonderful session on AI for code industry use cases. As a part of the FDP, Emerging Trends in Quantum Computing and AI for Academia and Research, which is happening in hybrid mode. As a token of respect and appreciation, I request Rajshekhar sir to please hand over a memento to Dr. Shivali Agarwal, Senior Technical Staff Member, IBM Research, Bengaluru. I thank all the participants and organizers who are a part of this activity. Now let's break for tea. Post tea break, we are going to celebrate International Women's Day. We have few activities, fun activities which are planned for the all staffs.
Activities for all the participants, not only for women.
For all the participants.
Sir, I wanted to make sure that activities are for the participants. Part of that is Women's Day celebration.
We can have a group photo.
We will now assemble for the group photo. So before that, I request all the participants to please assemble back. We can have some fun activities post the break. Thank you all. I request all of you to please come here for the group photo.
One second,
Yeah, that's why I thought I should keep it like that. Very much.
Come on, students, please come. You all the participants for the session, come.
You want to go back?
You can also go back.
Smile thing as well.
Share it with me also.
Yes, ma'am. Actually, my PhD was in statistics. And now I'm looking at, so what I spoke about, right, is application understanding. This is what I'm working, it's my problem. I'm working on very pleasant. So it is AI plus analysis.